Ladies and gentlemen, boys and girls, EA released the source code for Command & Conquer Generals 0 Hour. This happened about 2 months ago in a rare EAW to try to support the modding community, to give them access to the source code so that they can make modifications to this beloved game from 2003, very, very old. You can see here by the box, back when you used to buy video games that came in a box, glorious times to be a kid. I was in 3rd grade in 03, and the graphics just, captivating. But honestly, this is one of my favorite eras of gaming because the games were so simple, but they were so fun to play. You could get your friends on a LAN network and you'd get together and you would just throw armies at each other and have a grand old time. Now, the source code for these games is available. It came out on February 7th of this year. Now, note that the assets of the game are not included. That is still EA proprietary. So while the source code is available, you cannot compile it. You can't just build the game from scratch. Now, as a good hacker, that is what I am. I am a hacker. I'm an offensive security researcher. I'm a security engineer. I wanted to look into what's going on in the code of this game. Is there anything spicy? Is there anything fun that we could look at that may be a network attack surface? How is the security of this game? And so I did this. You can go into the source code of the game and read all the source code files that you want, but as a hacker, I am immediately drawn to things like game network. Ooh, how does the network code work in this game? If me and my buddies are on a LAN network, can I hack into their computer because they're using this game and it's written improperly? Understand that this game was written in 2003. This is well before cybersecurity was the thing. Code just had to kind of work, and when it works, okay, good. This is back before like the MS 0867, like just the word 0 day was barely a thing. So this is a crazy time in computing where it was kind of just the Wild West, shooting off the cuff and just hoping that the code works. I was going through this code, and there's a lot of code to go through, and in this video, I'm not going to cover all of it. Understand that this code was written by an entire dev team, an entire team of engineers over the course of multiple years. I don't have that kind of time. I'm a dad, but there are some fun little tidbits this video will go through. The first one you see here is lobby port, right? We want to figure out, if there is network attack surface, how do I get access to it? What port do I have to hit to open up another person's computer? Is there any fun stuff that I can inject into that port? And right off the bat, so in this room is my studio for YouTube. I have my actual personal office in the other room. I have Command & Conquer running. And you'll see here that in that room, I have it open in a game, right? So I made a local area network game, a LAN game, and you can see right off the cuff that that computer is broadcasting on port 8086, which is kind of cute, right? Because first of all, this is the port that is indicated in the source code, so we kind of have like a reality anchor. Cool, like it's doing what we think it's supposed to do. And also, 8086 is the short name of the Intel processor from a million years ago, so that's kind of fun too. Now, if we go into this source code, we can do the hacker thing, and we can zoom in and we can enhance, and we see that it's kind of emitting the same content over and over again, but you will see that this content is slightly changing, and also it's kind of just garbage, right? It's kind of just gobbledygook. There's nothing super fun in there, so I guess our adventures are done. No, obviously, this is low level, man. This is a channel where we hack stuff. What you can go into, actually, is you can read through the source code, and maybe they're doing a key exchange where, you have to connect to it over TLS and be given a sensitive key that you use to encrypt and decrypt traffic. Or maybe they're using XOR encryption, which, mind you, is not encryption, period, full stop, not encryption. This is kind of funny, right? So again, this is 2003. This is back before cybersecurity was really a thing. So they have these two functions called encrypt buff and decrypt buff, and there are actually a lot of funny things that happen inside of this function. So if you don't know, if you're not in the world of cybersecurity, XOR is not encryption. To do encryption, typically FISL networks, right, that are used inside of encryption algorithms will do XOR operations, but there's a ton of shifting and substitutions and like mathematical hardening on encryption that make it more secure than just doing the exclusive OR operation. So encrypt buff, for example, what it does is it takes a mask. The mask is just the value that you're going to encrypt with, and they set it to some default value. I will say the first very interesting kind of funny part is that they use a uint pointer, which for the Intel architecture is a 4-byte wide type, but then they leave the first 2 bytes of the mask as 0, and anything XOR 0 is itself. So they are by default just not encrypting every 2 bytes. So what they do is they take a pointer to the buffer, they cast it as a uint pointer, so they're pointing to every 4 byte chunks, and they're gonna XOR it. They're gonna say the thing pointed to with the uint pointer is equal to itself, XOR the mask. They do, just for fun, they increment the mask. They make the mask a little bigger so that they're changing the XOR value as they kind of run down the packet, but they're they're incrementing it by such a small value that for multiple operations, for like multiple iterations of XOR encrypting this, the value is still gonna have these zeros up in the upper nibble of the word. So there's just gonna be no encryption on those things. Again, I keep saying encryption, it's encryption in air. Decrypt buff functionality is the same. One more thing that's kind of funny, this assumes the buffer is a multiple of 4 bytes. The extra is not encrypted, which means that like if you have a packet that is 281 bytes, the 281st byte will not be encrypted. But also by this logic, it won't be endian corrected, meaning it won't be properly stored for network traffic, which is also kind of weird. But yeah, anyway, so that's super fun. This is the function that is called to handle all inbound traffic for the game. There's a bunch of debug stuff here. Basically, this is code that would be included in a debug build for the developers so they can see, oh, was there packet loss? Oh, what time is it now? Stuff like this, just to help them debug the game. But when we eventually get a receive, what the receive does is it reads off that UDP socket, that 8086, to a max message length value into an incoming, or actually no, into a buffer, right? We have this buffer here. They decrypt the buffer, which is great. It makes sense. We're gonna unwrap all that wrapping we did to encrypt it, and then we're going to call this function called isGeneralPacket. Ooh, what is an isGeneralPacket? So they do another kind of weird archaic thing. They compute a CRC on the packet. It's a cyclical redundancy check, which basically just means we want to see, is the data in the packet, right? Is the sum of all that data equal to the indicated sum, right? We're doing this to see if there are random bit flips on the wire. We're doing this to see if there are random errors in the packet. It also acts as kind of like a, do you know who you're talking to? Like, are you and I talking in the same protocol? Because if you and I don't do the same CRC, maybe that means that you're not supposed to talk to me and I can drop the packet. So what it does is the isGenerals packet is like a sanity check to see, is this person speaking my language? Should I even continue to process this packet? Now, what they do is they say, okay, is the CRC of the data, right? Calculate the CRC of the data. Is it equal to the CRC indicated in the packet? Okay, and if it isn't, drop the packet. Otherwise, continue. And then, if the CRC of the packet, if the header of the packet is equal to this general's magic number, and we're going to see that that's actually pretty funny here in a second. If it's not equal to this general's magic number, drop the packet. Otherwise, it is a general's packet. Let's continue processing it. Now you will see that if I go in Control-Shift-F for general's magic number, the general's magic number is equal to, drumroll, food. It's food. The number is food. So I thought that was pretty funny. We kind of are, we're taking the building blocks, and we now know generally what needs to be accomplished to take these messages apart. And so I wrote a little nifty scripty that literally re-implements the functionality that was done in C in Python, because the reason I want to use Python is Python has this thing called Scapy, where Scapy is a library for Python. You can read traffic off the network and use that to like pull packets out, and like they come in a byte string for Python, so you can like manipulate them. But also Scapy allows you to inject packets. So in theory, if we can decrypt and validate the CRC and the magic value, we then could also replay the CRC, replay the magic value, and inject our own packets without having the game source code running, which is kind of a cool concept. We use Scapy to sniff. A sniff is a Scapy function. We sniff for all UDP on port 8086, and we decrypt it. And then I print the decrypted packet both in hex and raw. And you can see right here, there is now plain text data. There's a lot of garbage here. There's a lot of garbage going on the screen, but I want to show you some interesting things. First of all, you will see the /r/foo, which also happens here, /0d/FO. That's the magic value. That is the general's magic number that must be indicated in the packet to make sure that it is actually our number. Also, you'll see there is this other magic value that is not a magic value. That is the CRC. That is the calculated CRC value of the packet that we have to validate as a receiver to make sure that it's actually a sane generals packet, right? And then after that, you'll see some pretty interesting ASCII text. So like I said, in my other computer, I have a user of this game sitting in a lobby waiting for other people to join. So inside this LAN API.h function, we can actually see all of the different types of messages that can be sent in this lobby context, right? We have from 0, request locations, game announce, all the way up to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what we're actually advertising here is that we are advertising, hey, a game exists. These are the options that are currently present in the game. There's a lot of fun things here, like we have the map that the game is playing. We have the CRC of my binary to make sure that me and the opposite player are playing the same version of the game. I have my serial number to make sure that they are not me, right? I can't join my own game. And also here, there's this fun little string which basically says all of the slots in the game, right? So you have 1, 2, -1, -1, all of the slots in the game and who is currently occupying them, what team, right? So team 1 is like, my team 2 is the enemy team, -1, -1 I think are closed, and these are like AI slots, right? So there's fun little stuff there, right there, and a bunch of other cool, just metadata about the game. Now, again, this is a piece of code base written by a team over the course of several years. I'm not gonna reverse engineer all of it, but you can see now I have the player low level X right here, just like back in the old days, XX, low level XX, death by night 1, 2, 4, like it's just fun. Okay, so I just went to my other computer and I sent a chat message in the game. Now you can see that it's a chat message here by looking at this. Again, these 4 bytes are the CRC of the packet. This RFO is the food value. It's the food number that has to be in the packet. And then you have this /n. The /n is the ASCII value for the number 10. And if you look at the source code here, the number 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is a message chat. Wow, look at that. And you'll see encoded in the packet is my name. So I have XX, low level X, and you'll notice that it's interleaved with null bytes. This is a function actually of Windows, right? So in the source code, they use these things called WCHARs or wide characters. They're a 16-byte character, and this is used for Unicode encoding, right? If you want to have a 2-byte Unicode scheme, you have to use WCHARs. And so when you do normal ASCII in WCHARs, what actually happens is you interleave the data with null bytes. So you have low level here, and then there's some more kind of like checksummy data. I'm pretty sure this is actually the game ID, so it's containing what game lobby the message came from, and then you will see that the message starts here. It says, wow, this is rad. Wow, look at that. All of the contents of the lobby completely decrypted again in air quotes, in plain text. What is interesting, I think, about this in general is that this is being broadcast to the entire network, right? So basically, if you're on a LAN, regardless of if or if not you are in the lobby, you are getting this data. I will say one more thing about the security of this code, and this is authentication, right? So we want to figure out the end state here is, can I inject packets? Can I send packets to somebody who has this port open and send fake data? Now, I was not able to figure this out in its entirety because, again, this is a huge code base. I don't have time to be doing this for all day, every day. I have a job, I have a kid. But what I will say is we have these functions, right? These are the callbacks that are handled by the transport layer when it receives the data. And you will notice something a little suspicious. The only arguments to these functions are LAN message, the message itself, right? And then unsigned int sender IP, right? So if we go to these functions in LAN API handlers, really the only way that it's checking to see if the packet came from the proper person is by the IP address of the packet. Now, if you're into InfoSec at all, you'll know that this is also a UDP protocol, which means there's no 3-way handshake required to get the data into the computer. You can just willy-nilly broadcast UDP, and you can just make up packets. The reason why this is important is that in UDP, in Scapy rather, you can spoof the IP address of the person that sent the packet. So I've created a class here called transport message. This is a C struct, which basically in Python allows you to write a struct definition, and then you can use these fields in Python and like add content to them, right? You have the CRC, the magic, the type of the packet. So if it's a chat message, if it's a lobby announcement, if it's whatever, and then you have this, I think the message length is 467, just based on what Wireshark is showing us here. But what we can do with this is we can make the transport message type, we instantiate it. We add the food magic, we say the type is a type 2, which actually is not what I want a type 10. This is from a different experiment I was running. And then we can say the message is la la la, again, this won't work. And then we can do the CRC of that packet using our CRC function. And then we can encrypt it, right? We can just add the encrypted data to the packet, print it out just to prove that it's the right data. And then we can actually, with Scapy, just spoof that the source came from my other computer. This is not my IP address. This is on a different computer. But because it's just going out broadcast to the network, I can say, hey man, this packet actually came from this other guy. What are we gonna do about it? And then the source code will just use that IP address to determine what functionality to take, right? There's no authentication other than, is the user at an IP address? Okay, let's do a thing. Before we continue, let's take a break and hear a quick word from our sponsor, me. Today's video is sponsored by me. I honestly believe that if you want to get into the world of cybersecurity, software security, programming, really anything, you need to know how computers work at a fundamental level. And in my opinion, the best way to do that is by learning the basic languages that run the world, by learning C and assembly. With my courses, you can learn the C programming language with 0 to Hero C Programmer. You can learn how to write network code for C, how to use threads in C, and if you want to, even write your own HTTP server in C. For a one-time price, you get access to every course, as well as a private Discord. You can ask me questions. You can't write good code without knowing the fundamentals. And where do you learn the fundamentals? On the Level Academy. So that's it, guys. Pretty fun little video. I love doing stuff like this. Dude, if there's ever a chance for you to read the source code of a thing that you used to play, or some big functionality, some big program comes out that has a lot of network functionality, go read the source code. Go check it out. It's a lot of fun. I love this stuff. From a security standpoint, I would give this a high 4 out of 10. The reason I don't give it a 0 is all of the operations that are being done here are actually using the C++ string class, which is really, really hard to get wrong. So they're not doing like stir copies or mem copies, they're doing like .concat, which is very, very safe. But other than that, XOR is an encryption. Authentication cannot be done strictly off of an IP address, especially with UDP data. Yeah, but that's it for now, guys. Thanks for watching. If you like this video, if you like stuff like this, leave a comment down below, please. Let me know. Say, hey, low level, how you doing? And then hit subscribe, and then go check this video out, which I think you will also enjoy. Okay, goodbye.